Right, well, yes, thanks for inviting me, guys. Yes, I've given this talk a few times. Hopefully, you'll uh, find something new. Um, it's not as well prepared as I would like because Thursday night, when I was going to write the talk, this thing happened. Um, so anyway, let's get on with some amateur satellite stuff. So what's up there? I don't know whether anyone here is particularly new to the subject. Hopefully, okay, yep, good. So there's some people who are going to benefit from this then. So um, they've got all technical names, but basically we've got some flying repeaters where you can talk to them, and then they give out the same signal back down. And so as it flies overhead, you can talk to other people through that way. We've got some technical stuff where the satellites are transmitting data. Usually it's about the flight path, so when it's in light, what the battery voltage is, all that sort of thing. Then we've got the ISS. Hopefully you've all heard of the ISS, which does lots of useful amateur stuff. And weather satellites getting weather imagery. It's not quite AMSAT kind of thing, but it's working satellites anyway. And finally, we'll talk a bit about Oscar 100, which is the geostationary satellite. So I'm gonna whiz through some of this. So the first problem people have is these things are up in the sky, and mostly they're moving quite fast. So you need to be able to find them, and you need to be able to work out where they're going to be so that you can work them. The default sort of go-to place to find out what satellites are up there is this page, the AMSAT status page. And basically this just lists all the currently interesting amateur satellite workable stations. I think yesterday there were 32 on the list, so there's plenty of them up there. So you can see the ones in blue are active. So the ISS is doing data stuff, and AO-73, there's SO-50 as well, which isn't on that list. But so there's plenty up there to go and find. Once you've picked a satellite that you want to work, and you can see from this diagram that it's actually doing stuff, and other people are working it, then you need to find out about its orbit. There are plenty of websites. Just search kind of satellite and orbit, you'll find one. This is just one I use quite a lot, n2yo.com. It gives you this sort of picture. I think we've got so here's a zoom in of it. So it shows you the orbit, and because of the map projection, obviously it's going round in a circle round the Earth. But because of the orbit and the map projection, you actually see it as this wavy line sine curve. And also, of course, the satellite isn't that high up, so it doesn't shine on the whole of the part of the Earth that it sees. It only shines on a bit, and that's what the circle around the satellite is. So everything inside that pinkish circle can see it and have radio communications with it. So that's called the footprint. And the path obviously is useful. So you can see that particular, that's the ISS, it's a while ago. That one is not quite going to be workable when it comes up to Europe. But again, be aware that that footprint will change because of the map projection. It won't always be a little circle. As it gets up further north, it'll turn into an oval or whatever. So yeah, map projections do cause a bit of trouble. Also, if you get quite advanced in this, you're going to want to be able to track the Doppler. We'll talk a little bit more about Doppler. This is a little program by a guy called David Taylor, WXSat, WX-Track, which lets you connect up to your radios, and if you've got a radio that can do cat control, it will handle all the frequency problems for you for Doppler, but we'll come back to that in a moment. Okay, so I mentioned these flying repeaters, FM transponders. Like I said, there's loads up there. I got a soft spot for SO-50. I did quite a bit of working on that a while back. And everybody's got them up there. There's one on the ISS, there's China, there's Saudi, Americans, there's lots of them up there. Antennas to use. Well, yeah, let's make your own. This is my favourite little prop. So a bit of wood, a couple of bent coat hangers and a couple of bits of wire, and you can make yourself a 2 and 70 antenna. Very, very cheap, I guess. I didn't pay anything for it. You need to make a little diplexer. That's this thing here, which has sadly fallen apart in the car today. But again, there are plenty of designs online. Most people will do this sort of thing, or you can buy the elk or the arrow antennas. We were going to have them here, but we haven't, unfortunately. They all require that you hold the antenna and point it. So I had this great invention. I made the handle longer so that you can put it against your hip, and then you can move it around and you don't have to take all the weight on your wrist. So there you go. That's a simple thing that you could do. We'll talk a little bit more about that in a moment. Yeah, so you can go and buy them. They're not all that expensive. Or you can make your own, and there are plenty out there. Kent Britton, who's one of the keen, well, he's a anything microwave guy from America. He often comes over to the club. I don't think he's here today. He's done quite a bit on designing these things and optimizing them. So, does anyone not know what Doppler is? Okay, so I can skip over that. Often I give that in clubs and they say, "Oh, what's Doppler?" And then I end up having to do train impressions. It's not a good thing. Anyway, so we've got to correct for the Doppler, and it's not big for these satellites, but it's enough to put an FM receiver off. So, how does this sort of thing work? Here we go. So you need a good radio. I have heard that people have worked these satellites on Baofengs, but a decent handy, that's a Yaesu handy, will do the job. We've talked about the diplexer, that you can buy them, but you can make them. The only other thing you need is a CTC SS tone. So how do you work them? Well, you use one of those programs to work out where it's going to be in the sky. So, for instance, if you know it's going to come up over there, it's going to go up to maximum altitude over here, elevation angle, and go down over there, and it's going to take 10 minutes to do it, then you know it's going to be there at 5, there at 2.5, and so on. So you can get in your mind a picture of where it's going to be at what time. Then the trick is to I'm going to have to put the microphone down. I'll demonstrate this. Okay, I'll shout. So you've got your radio, like so, and on the radio you've got a tuning button so you can change the frequency slightly, as you know, with the Doppler. So when it's coming towards you, you're going to see a higher frequency than when it's going away from you, so you need to bear that in mind, and we'll show you some of that in a minute. And so you start off over here, you're listening to your radio, you hear something, you turn it to get the best polarization, you move around as you keep an eye on time, keep your watch on your wrist, and as it goes round, you should be able to track it, keeping an eye on the frequency and on the polarization. Recommend that you do a couple of passes without actually using the radio to get the hang of it, to listen to see how people are doing. These things happen quite quickly. It's usually sort of someone calls CQ, someone goes back to them, they give you a report, you give them a report, and that's it, and they move on to someone else, because you only get a few minutes to do these the whole pass. So there's quite a lot going on. You're looking at your watch, you're looking at the radio, you're looking at the polarization, and you're trying to track where it is in the sky. So, but it's very rewarding when it works. It's not like you just called CQ and someone came back to you. You have to work to get these QSOs. Luckily, there's another AMSAT page, Beginners How to Work the FM Satellites. It has a recommended set of frequencies, so those are the ones that you want to to program up. You're going up on 2 meters, down on 70 sems, and that gives you the Dopplers. So you only correct one of them. The satellite will handle the rest of it effectively, and that's it. So you know where it is. You've got the tuning. You're working it around, and eventually you can have the QSO, and it's quite good to get that. Okay, there's more than one of them. Okay, so let's have a look at the ISS. Lots of things going on up there. APRS, for those who like to do tracking, you can bounce your tracking signals off the APRS transponder up there. You've got another one of these voice things when it's on, and occasionally they do SSTV, which is quite rewarding. Again, you can usually get an entire picture or a picture and a half in a pass. So that means mostly at the moment it's been the Russians have been doing SSTV, but we have had some American ones, usually celebrating some event. Antennas, you don't need to worry about this sort of thing. Very, very simple. If you've got a cell phone with what have I got there? Robot 36. I use Droid SSTV on my Android phone. Put the speaker of your handy somewhere near your microphone on your Android phone, and roughly get the signal, and you'll probably get a picture out of it. So it is that simple. If you want to go up a bit of a notch in quality, collinear on the roof. I've done it from the collinear on my car. I've got a white stick on my chimney, like most people, and these will all get good pictures down from the ISS. What radio? The little RTL blue dongles. I don't know if everyone's familiar with these things. They're TV adapters. You can get them on eBay. I think they're about 20 quid these days. Or if you want to, I don't think I've got mine here. There's a silver version of it, which is a little bit more expensive, but a little bit better. Or you can go up to one of these RSP SDR Play things. They're £150. I picked that one up for a tenner at a radio show. And they do a great job as well, so I'd highly recommend any of those. And as I said, the handy for doing pictures is quite fun. There's a little plot I got of things going on from the via the ISS for the APRS. You can see I was working on the list there, and of course it's got a big footprint, so you can see people, a lot more people than you would normally get in your normal zone of an APRS 2 meter. There's a picture I got, so as you can see, reasonably high quality. That's one of the better ones, but yeah, you can get some pictures. If you get plenty of pictures, Aris will send you a little award. So if you're an award chaser, there's one from space. That was 2017 as well, I think. Okay, SAIL, the Oscar 100. So this is a different beast. This was a game changer for AMSAT, really. It's a geostationary, so it doesn't move, but it is quite high frequency, as I said, 10 gigahertz down, 2.4 up. Now, the reason they picked 10 gig down was that you can use a standard satellite receiver dish and a standard LMB, and you can actually receive this. So if you've got an old Sky dish with a Sky LMB, it probably will do the job. It might not be great, but it will get you started. If you have a look downstairs in the AMSAT thing, we've got a rusty old dish. I don't say the rustier the better. Well, actually, I probably do. But it's up there, and you can use that size of dish. So it is more challenging. It has a narrowband transponder, so you can do voice. It's okay with the right bits of software. It's better. But you can also get into the amateur TV. BATC have worked very hard with these guys to get a lot of TV stuff going. We'll talk a little bit about that. So the challenge of finding things here. You don't have to worry about finding the satellite. It doesn't move, so you just have to point your dish in the right direction. You do need to worry about where to go on the band. So this is a band plan. On the left-hand side, you've got the big beacon, which is a 2 mega symbol beacon. So it's basically just all the time it's transmitting TV pictures. And then on the right-hand side, you've got various people using the narrower TV signals. And you can see there's lots of gaps that you could just pick a gap. Over on the right-hand side of this screen, there's a chat room. You can go into the chat room and say, oh, I'm going to pop up here and I'm going to be using this type of TV and this modulation and so on, because there's all sorts of different options. So that's the way people can find you, and you can have a QSO, a video TV QSO. So receiving it, as I said, Skydish, 10 gigahertz horn will work for those doing microwave stuff, but most people are just using a normal dish with a decent LMB. If you want to do receive only, those little RTL SDRs, they're not great, but they do work. You can hear the QSOs. The ATV receiving these pictures, you need to build yourself one of these mini tuner hardware. So if you are interested in that, go on the BATC website, or downstairs they've got a great setup down there with demonstration. I think it's all running. I'll look at Joan to see if she says yes, it is. Yeah, so everything's going downstairs. So yeah, if you are interested, take a look at that, and the BATC will sell you all the kit. It's an easy kit to make, and you can start receiving TV pictures very, very quickly with just very simple hardware. Astra LMBs, as I said, you do need to get a bias T in there if you want to transmit. Now, actually, you want the bias T anyway, because you need to power the LMB. So that's just a little expense. And again, the AMSAT or BATC will sell you a little kit, one of those. Receiving it, TV, you can do from PC or Raspberry Pi. There's one over there. And recommend a program called SDR Console. It's a little bit hard to get into, but it can make a really good improvement to tracking the signals to make sure that they don't wave around, drift around with temperature and so on. Basically on a PC or on your radio, if you're doing narrowband stuff, the LMB comes out at 700 odd megahertz. So if you've got a radio that can receive in that area, most SDRs will, you can pick up the SSB or CW for those of you want to bash the metal together. Okay, so transmitting is harder. No two ways about it. You need an antenna that can transmit on 2.4 gigahertz. You need a bigger dish if you want to transmit TV pictures. The little sky dishes aren't really up to it, but a 1 meter dish will do the job if you've got enough power. This thing called the Potty Patch of the Year, great little invention. It makes life very simple. It's 2 discs, goes on front of the LMB, and then it'll give you the 2.4 transmit as well as the receive. Radios, again, you're in a bit more difficult territory here, but any up converter, there are plenty available on the market now. Or you can use the Plutos or the Limes for those who've got those, and it works. You just have to get set up with a bit of power to transmit, and you can see your own signals. Okay, again, transmitting, if you want to transmit TV, the ports down, which is a Raspberry Pi based thing, it's a bit more complicated again, but it's easy to do. And there's so much support. The BATC have lots and lots of resources. So again, you can do good stuff there. You're going to need an amplifier for voice. One of these little Wi-Fi amplifiers, very easy to mod it up to do your job, and that's all you need. Just feed that Wi-Fi signal, or the signal out of that Wi-Fi amplifier, because Wi-Fi is 2.4 gig, of course. Just feed that into your patch of the year antenna, and you will see your own signals. These are I don't know what they cost. They're £20 or £30, something like that, from China. Okay. Yeah, I'll just say it's very rewarding. When you first get Oscar 100 and you receive stuff from it, it's a real buzz because you do again. You have to work at it a bit, but it's doable. Okay, we'll talk a little bit about these telemetry sats. So lots of things. The FunCube is a AMSAT project. In fact, I think all three of those are. Are they still up there? Does anyone know if? Because I think, yeah, I remember there was some concern about one or two of them not being there anymore. But anyway, so there's a lot up there. They all receive different types of information, and again, your white stick on the roof or a collinear on your car will do the job. The SDRs, I've used that blue SDR. I think it's say 20 quid's worth. It's hardly worth worrying about. GNU radio, GR satellite for Linux on the Raspberry Pi or PC, or plenty of other bits of software. Again, everything's online. Go have a look, trawl around the AMSAT website to find out what you need. There's a couple of pictures. These things are 100 by 100 by 100. They're about yay size, and they're hurtling around up there. Yeah, they seem to be very reliable, very easy to get. This is one of the dashboards, so this is a bit of software that's going to receive the telemetry. Obviously, it's not going to be something easy that you can read with your ears. You're going to need a PC. Feed it through the sound card. You get something like this. This is an eye diagram for those who are familiar with that. It just basically shows how precisely you are tuned in, locked into the signal. And that's the sort of information you get. It's a bit cluttered, but there's a bit about the power amplifier, about the what the various receivers are doing, and voltages somewhere, and temperatures, and just generally interesting stuff. But the great thing about FunCube is that when you receive some of this, you're receiving just a little snapshot. But there's a thing called the data warehouse where you can put all this data up to a central server, and it collects everybody's data. So you pretty much got a perfect record of all the transmissions anywhere in the world, anywhere around the world, from the past 10 years, is it? It's been up nearly 11 years. So that is an incredible resource. And people are always being asked, if you're interested, come and have a look at the data, because there's a lot of data mining that people could get into if you're interested in that aspect of it, about all the sort of the temperatures and so on, and basically just the life cycle of 10 years of a satellite and what it does, what it can do. So that's a bit of citizen science. Again, it's very easy. The software you download just has a button to say, are you happy to upload this? And you say yes, and off it goes. And there's another one. I think that's, is that FunCube? I'm not sure. Anyway, that's the information that it's giving you. So it's all very similar. And again, if you upload some data, you can get a little certificate. So again, if you're a certificate chaser, that's another one from space. And yeah, the FunCube guys even give you a QSL card, so you can have a I received from space QSL card. Okay, we'll talk briefly about the weather satellites. There's a lot of them up there. The NOAA ones are the interestingly easy one to get. They're FM. They're just a little bit below the 2 meter band, so with a 2 meter antenna, again, a collinear, you can go get those. But you can do some interesting stuff with some other antennas. These are circularly polarized. It's easy for me to say. So it's not quite as easy as just putting up a dipole or whatever. But turnstiles, QFHs, they're all quite easy to make. If you go downstairs and have a look at the AMSAT stuff, there's some examples of some homemade bits of copper heating pipe bent into circles. Or the horizontal V, just think about this size, made out of a coat hanger. Again, the blue dongles do fine, and there's loads of software online. This is a lovely little thing. A bit of wood, a chocolate block, and a bit of coat hanger, and you can make up a little antenna. Um, I like to show this slide. We were at an event a couple of years ago, and this guy Mark Phelan came up to me, and I was doing a demonstration with weather satellites, and we had a mobile mast, and he said, "Oh, I just built one of these little antennas. Can I try it out?" And I thought, yeah, this is great. So we put his little antenna up on the mast, and we got that picture. It's not great, but this guy had just seen us doing this, gone online, found that earlier antenna and made it with a couple of bits of wire. And that was really inspiring. It's really great when people can spend literally 5 minutes doing something and get some pictures like that. So I mean, the trouble is, you do that, you get hooked. You want to do something better, so you wire up to your collinear on the roof, and instead of having QSOs with someone next door, you download some weather pictures. For those who know, collinears are donut-shaped radiation patterns, so there's not very much received above them. So when it goes overhead, you get a fuzzy line where the reception isn't so good. The colours are kind of false colours, so the software puts on the grid, obviously, and the outline of the countries. But even without that, you can still see the countries on the display, and obviously you've got all your weather patterns, so that can be quite rewarding. There's a picture of a turnstile and this double cross antenna. I've never made one, but apparently they work quite well. The thing about the QFHs, these weird curly things, and also turnstiles, is they receive in the whole hemisphere. So you don't have to move them, you just put them up and they receive in the half of the sphere above them. So the satellite comes over the horizon. Yeah, thanks. Sorry. Yes, okay. Yeah, and then if you want to get that little extra bit, because you want to overcome that little fuzzy bit in the middle, these guys, they're a little bit more than that now, but the Sawbird, they're basically a filter and an amplifier. You can just grab one of those, plug it in line. It's a USB powered thing, and that gives you something like that, which was with a QFH with an amplifier. Yeah, very rewarding and quite pleasing. And that is that's the end of that. As I said, most of this lot is on demonstration downstairs. The AMSAT stand, the BATC stand can show you everything you'd like to do, and there's an Oscar 100 receiving station. I think, is it transmitting as well? Yeah, yeah. So yeah, so you could go downstairs and have a QSO on a satellite right now if you wanted to. Thank you very much. Any questions? Do we need to give you a microphone? Oh, there we go. There's one there.
Thank you very much for a very interesting talk. Just wondering if there's anything equivalent to Oscar 100 over the Pacific, and if not, whether if there's any plans to make.
You'll need to ask somebody else. Anybody? I don't think there is at the moment. No. It's one of those kind of weird things that obviously the Qatari people wanted it to be over them, and that does preclude them being over America. So, but I'm sure there are plans. I don't know. You read about these things all the time, but so at the moment, no. But that said, come back later because there is some people. Where did you get to? North America did actually get into the satellite. So yeah, there's a talk on that sometime later today, I think. Next session. There we go. Okay, so stay for another 5 minutes, and you could hear about the. Oh, okay, half an hour. Yeah. Any other questions? This one over here. Sorry.
Hello there, that's better than me shouting. With weather satellites, obviously you can build a dipole, get an SDR receiver. What software in the PC would I need?
Okay, yeah, that's a good question. Have I got an answer to that one? Yeah, so this program, WX2IMG, works very well. It just listens to a sound card. So if you're using one of those little blue SDRs, you need a virtual audio cable, if you're familiar with that, just to get the audio from your USB into the receiving program. WX2IMG, it's another one of these really great, almost plug and play type of software. You do need to track the Doppler for the satellite, so that that little program I mentioned right near the beginning, WX track. Again, you just put in the frequencies, tell it which satellite you want to receive, and it will track the Doppler for you. And then this program will you'll just see the lines appearing on the screen as the satellite goes over.
Thank you.
There are, of course, everything else for the Raspberry Pi. There's this NOAA V2 thing actually is quite good. It can receive some other satellites as well, which do higher res images. So if you're a Raspberry Pi or a Linux fanatic, then that's a good way to go as well.
Satellites these days have the ones used to be in very high orbit. All those have passed and have this such. Used to be the Fuji Oscar ones and things were going.
So there's lots of different orbits at the moment. Most of these are LEOs, the telemetry type ones. I'm not sure what the weather satellite altitudes are. I think they're probably LEOs as well.
But in terms of QSOs, there's only these low orbit ones now left as such.
There aren't many. I don't think there are any elliptical orbit ones. Anybody else? No. Okay. Brilliant. Yeah. No, so yes, you from way back, there used to be the ones in the big elliptical orbits, which would be visible for a long time. But yeah, they don't seem to have any of those. But then Oscar 100 is way out because it's geostationary. It's
Yeah, hi, thank you. I was just going to say one thing on weather satellites I've been playing with is some software called SatDump,
right.
which is absolutely brilliant. It works really well with the dongles, works on Raspberry Pis, Linux and Windows, and it's all fully automated. You don't have to do anything. You just load the software, select the dongle, connect it to an outside aerial, select the satellites, off you go. It does all the tracking, does
Nice.
all the Doppler, does everything for you, and it's
Okay.
free.
Brilliant. There you go. What was that? SatDump. There we go. Okay, there's another one. Yeah, it's brilliant, and it's so, as you say, it's very easy to do, and very rewarding because you get pretty pictures from space. Okay. Well, I think we've run out of time, so thanks very much, and we'll see hopefully some of you downstairs with the AMSAT or whatever.
Thank you, Heather. Can we get a round of applause, please? One thing I would add is there are a lot of Internet of Things satellites up there at the moment, transmitting on 433. And if you look up an application called TinyGS, it runs on an ESP32 out of the box, and you can get satellites up to about 2,500 miles away, just running on a white stick. So that's another one to look at. We're now having a break for about half an hour. Come back in at 10:45. The next one will be, as Heather said, it'll be a report on the operations of QO100 from North America. Thank you very much indeed for your attention.